Now, in the rest of this, what we're going to do is we're going to apply those identities, sum to product identities, in a couple of problems in 8a and 8b. So let's go down at 8a. We have 3 times the cosine of 37.5 degrees times the cosine of 187.5 degrees. What we want to do is we want to be able to rewrite this so that we can use our product to sum identity. So it's going to be 3 times. Now, this is alpha and this is beta. So we want to find the one that says the cosine of alpha times the cosine of beta. And we're going to make that replacement of our product to sum. So it's going to be 3 times 1/2. Then I need another cosine of alpha minus beta. So it's 37.5 minus beta, which is 187.5, parenthesis. Then plus the cosine of your angle, your first angle, alpha, which is 37.5, plus 187.5. Parenthesis, square bracket, square bracket. Then we can finish our simplifications. So if we go ahead and simplify inside our brackets, here we have 3 times 1/2 is 3/2, times the cosine of, if you take 37.5 minus 187.5, that's a negative 150 degree. Then plus the cosine of, then if you add those two angles, that is 225 degrees. Only one bracket's needed now. So from here, what we want to do is evaluate the cosine of a negative 150. So a negative 150 goes 150 degrees in the negative direction, leaves us with a reference angle of 30. Opposite 30 is 1. This is the square root of 3. This is a 2. These are both negative, and we want the cosine value. So we still have our 3/2 here. We want to take it times the cosine of a negative 150, which is a negative square root of 3 over 2. We want to add to it the cosine of 225. Cosine of 225, getting a reference on that, puts us over here at 225 degrees. So that's a 45-degree reference angle, which is a 1 square root of 2. These are both negatives, and we want the cosine. So it would be a negative 1 over the square root of 2, or if we rationalize, it's the negative square root of 2 over 2. Since these have a common denominator, we can go ahead and write them over the common denominator. It's a negative square root of 3 minus the square root of 2, getting rid of your double signs, all over 2. Distribute your 3/2 through, so it's going to be a negative 3 times the square root of 3 minus 3 times the square root of 2, all over 4. Okay. So that's 8a. Now let's come back up. We'll clear and we'll try 8b. For 8b, we see that it's a cosine of a difference. So what we're going to do is we're going to look up our cosine of a difference and try to go from a sum to a product identity. So first thing I'm going to do is I'm going to think of this as alpha and this is beta. So I'm looking for the one that matches the cosine of alpha minus the cosine of beta. So our sum to product identity says that we can rewrite this as, so this equals negative 2 times the sine of alpha plus beta, so it's going to be 7 pi 12ths plus pi 12ths all over 2, then times sine of alpha, which is 7 pi 12ths, minus beta, which is pi 12ths, all over 2. So it's going to equal a negative 2 times the sine of, this is going to be 8 pi 12ths over 2, times the sine of, it's going to be 6 pi 12ths all over 2. And those two can simplify down further. So we'll slide down. So negative 2 times, now this is divided both by 4, 2 pi thirds. Then it's divided by 2 over 1, so I'm going to simplify by taking 2 pi thirds times 1/2. And we got the sine of that. Forgot my sign. So really, if I just want to simplify, it's going to be the sine of pi thirds. And over the side here, I got 2 pi thirds that we were dividing by 2, which is the same thing as multiplying it times 1/2, which cancels those out. So there's where the pi thirds came from. Got to take that times the sine of, and pi, there's 6 pi 12ths is pi halves. So over here I'm thinking that's pi halves divided by 2. So that is really pi halves times 1/2. So we get pi fourths. So the sine of pi fourths. All right, the sine of pi thirds. Pi thirds, that's a 60. If you go back to degrees, that's a square root of 3, 2, 1. So it's a negative 2 times, this is the square root of 3 over 2. You got to take it times the sine of pi fourths. Just in the previous problem, we had that one. That was the square root of 2 all over 2. So then we got to multiply all these together. So this is like a 2 over 1. So I'm going to cancel this 2 with that 2. We're going to have a negative 1 times the square root of 3 times the square root of 2 all over 2, which could be written as a negative square root of 6 all over 2. So a couple of different examples of showing you product to sum and sum to product identities.